Hello guys, this is Yash and this is the fourth video in my series where I'm learning Sui by doing live stream of my live coding sessions. And in this video I would try to create a protocol or a smart contract where users will be able to stake some tokens to gain some permission objects which they can use in some other smart contract to get some authority or access. So let's get started. Let me first try to create a new move contract. So I think Sui move new and then the contract's name. So let me give it like permissioning system or something like that. By the way, if you have not checked my last video on a live stream, there I have talked about how to create a staking contract. Like I was not aware of that, and I did some research in that last video and I found out how to create staking contracts in Sui. Let's not use VS Code. Actually, I find that Rust Rover is much better IDE for Rust and Move. So let's use that. Let me open this project. So this is the project. Okay. So I was thinking of also creating a token and not using the Sui native token for testing. So let's create a faucet contract that is going to issue these new tokens. Module, and let's call it token faucet. Okay. So let's create a witness variable. So if you don't know, a witness variable is a variable which can only be initiated once, or a struct which can only be initiated once, and this is used in the initializer's first parameter, so that we know that like if initializer can only be called once and this variable can only be created once, like whatever code is inside initializer can use this witness variable to uniquely identify whether the contract is created for the first time or not. And the name of this variable is always like all letters capital of this contract. So the contract name was token faucet, that's why the name of this struct is token faucet, all capitalized or to uppercase. And this has only one trait, which is drop. And then we need to create an init function, and the init function is neither public or like it doesn't need any identifier. It's just like public. Sorry, it's not public. It's just func init. That's it. And then we pass the witness variable, which is of type token faucet, and we need the context, which is going to be a mutable reference of token context. Transaction context. And then let's create a new coin. So a coin has a treasury cap, and a treasury cap is the like capacity to create to manage the supply of this token. Coin create currency, and in the create currency we need to pass the witness. And let me check the other parameter types. So basically, like, this is a really good documentation which is provided on the Sui official documentation page. I have not checked any other source yet apart from a GitHub repository for checking how to create the staking contract and this Sui documentation, and these both the resources were really good. So we might be able want to find like how to create a coin somewhere in the advanced topic, asset, no, where was it? And Sui 101, and create coins. Yeah, this one. So I'll just copy this object. So this is going to be it, and then the transfer package. Okay, let me try to import it. And then there's takes context. I don't know why this is not working, but self. Oh, that's why. No, that's not the reason, I think. Okay. And let's just use it as a share object. Create a new struct which can be the faucet, and the faucet will have the treasury permission, so we can do the treasury, which is going to have the treasury capacity of type token faucet, and then we can encapsulate this in the faucet property. Yeah, and let's create the mint function. The mint function is going to take the amount, which is going to be UN64, and the context of this transaction, which is going to be a mutable reference of txcont, and then we need to get this object. Okay, I'm not really sure how this is going to work. Wait a minute, let me check. I think the shared object needs to be passed into the function as a parameter. So we will pass the faucet as the faucet. But yeah, we can't pass the faucet as object, but as a mutable reference. What's the problem there? Okay. Okay, so we need to pass in the mutable reference of this treasury to the mint function. I'm not even sure if we need to pass in the mint function, or maybe we do, and we need to return the assets, so like coin of type token faucet. We need to get coin. Yeah, I think this might work. Okay, so the token contract according to me is complete for now. So we are just having a mint function where anyone can mint any number of tokens, and basically he will get the token object, the token contract, sorry, the coins back, or we can get the coins here and then do the transfer, public transfer of coins to the TX context, sender of the context, and then remove this. Okay, I think this makes more sense. And then let's go to the permissioning system. So now here, what we will do is again create a witness. Now the witness is public struct and then the capitalized, the uppercase contract name. So system, and this has a drop parameter. Then we have a fun in it, which take a witness, which is of type permissioning system, and then it takes a context, which is a type of mutable context, mutable transaction context, and for now let's leave it empty, and just what do we do? So we need a stake function, so let's do a fun stake, and let's also create a staking pool. So public struct now the staking pool is going to have a ID which should be of type UID, and this has a key. Okay, so the UID object is in Sui object UID, and it should have so now what do we want to do? Let's also create the permissioning object. So whenever a user stakes some token, he will get permission. So that would be like what do we say it? Staker cap. So staker capacity has a key. It must have a ID. So on staking, we take certain number of coins, which is of type coin, of type token faucet. Let's import this token type. And so on init, let's initialize the staking pool. So that would be transfer. Okay, let's just remove this. Transfer share object. In the share object, we need to pass in the staking pool, which is going to have an ID, which is going to be a object, new context, and yeah, that's it, I think. Okay. And in the stake function, we are gonna get that staking pool. Now what? So there would be a initial amount, which let's say is a UN64, and then there is a minimum amount which is UN64. So basically I'm saying that every time someone creates like someone stakes for the first time, he needs to deposit this initial amount, which is always going to be higher than the minimum amount. And the protocol will have a provision that if the user is going to do something wrong, then his funds will be slashed, and if they go below this minimum amount, his permission, like his staker cap, should be revoked. Like I still need to figure out how to revoke the access of the staker cap from some other account, because the staker cap itself is going to be owned by the user. So that we need to figure out. But then okay, so let's say the initial amount of token, let's say we call it 1,000, and the minimum amount, let's say, is 500. Then we need to find the coin balance of coins should be more than equal to and here also we need to get the reference of this. Expected. Okay, so we need to pass in the reference of this. Invalid between an integer type and but found balance. Okay, so not the balance but the value function should be used. And if this is the case, or I should say assert here is a macro which will throw an error if this is not the case. So the error could be represented here by using a const keyword and then error. Then we can have different error names. So let's say not enough funds, and the error code is 1. So we can pass in this error here. So if the value of this is more than equal to the minimum amount, that's fine, but let's do initial amount and this should be equal to this. Okay, then what should we do? We should also have a balance of the staking pool, which should be of type balance of token faucet, and this should be having a balance of 0. How do we have balance? How we do the balance 0? Okay. Zero of type token faucet. Okay. The staker cap should also have a balance. Now I'm thinking like this balance object not only stores the value but also stores the like physical balance of the coins. So this should not be UN64, but if this is also type balance, then there would be a problem that the physical value should be stored in 2 places then. So I should make it UN64 instead, and maybe call it the value. Yeah. So if this is the case, then let staker cap equal to staker cap and id object new. Takes the context. Okay, we need to pass in the context, which is a mutable reference of tx context. The value should be coin value of coins. Okay, and we can also have this more than equal to. That is also fine, I think. And once we have created this cap, we need to transfer this cap to the user. Or I'm thinking, should we make it a shared object? I mean, that could also work if we make it a shared object. That would make a lot of sense actually. So there would be like a new cap, which is struct, and let's call it like admin cap or slash cap. So do we call it slash? Yes. Let's call it the admin gap. So whichever program will have this admin gap will be able to slash users fund. Okay. Okay, yeah, this makes sense. Let's transfer this cap to public transfer the admin cap to the user. So tx context sender of the context. Now we need to transfer the staker cap also to the user who is calling this function. But before that, we also need to like take these tokens, take these coins, and add these to the staking pool. And I think, I'm not sure, but like maybe this should be a shared object instead. Yeah, I think this should be a shared object. Then this would also have like a owner. What is the type of this? This is the address, so maybe like owner, which is our address. Okay, and maybe before doing this, we need to figure out which was the previous owner. How do we get that? So there could be another function which is merge cap. And that would take like 2 staking pools, not staking pool, but the staker cap 1, which is of type mutable staker cap, and staker cap 2, I'm again thinking that this should be transferred to the user, maybe. Check this. If this is logged to the protocol, then the protocol will be able to slash the funds. Okay, right. So maybe let's transfer this. Transfer this to the DX context center. And let's just forget about this for now. Let's make this a mutable reference. And in the staking pool, let's just do this. Staking pool dot let's do the increment the balance. I don't know how, but I think coin from balance get balance join, maybe join will be used, or put maybe put. It takes the mutable reference of this along with coins. Yeah. I think this should be fine. And then there's another function which is slash. It takes in the admin cap reference, and let's make another function which is to func make slasher, or should we not? I'm a little confused, but I don't know if this is the right word, but let's call it make slasher. And basically what this function is going to do is give a program the permission to slash another, like slash the funds of a staker if they own the staking, not the staking pool, but the staker cap. So let's make the slash function. Basically what this slash function is going to do is take some coins out of the staking pool and give it to the program which is calling this which is having the staker cap. So I'm assuming that if you want to use this staker cap in some other program, like if you want to use this permission in some other program, you will have to lock this permission into that program and then you are going to use it. But to lock this permission, you will first give this staker cap to that program, and then that program will be able to like log this or do something with the staker cap, and then at the end of the transaction or the flow, it is going to return you the staker capacity. But like in between, if you did something wrong, then that program will be able to slash you. And so this function is going to be called by that function to slash your funds from the staker cap. Yeah. So I was thinking, like, if the staker cap is not having enough funds, like if the staker cap, let's call it staker cap, which is of type mutable staker cap, and let's get the amount which you want to slash, and the context, which is of type mutable tx context. You want to get the coins, which is of type token faucet back. Then you're going to first check this. So I'm gonna make another function which is going to check if the staker cap is usable or not. It's just going to give a bool. It's going to check. I'm also going to take the staking pool. Which is so this value should be more than equal to the minimum amount, then it would be usable. But if it is not usable, I can do usable staker cap staking. So let's get the pool first. Maybe we don't even need the context, but let's just provide it anyways, because I don't know if the context is required for the transaction or not. And let's create another error, which is unusable unusable staker cap. Let's call it second. Yeah. And the third would be if the value of the staking cap is going to be less than the amount, then this would be triggered, which is not enough funds, which is fine. Then there is staker cap dot value, and it would decrease by the amount. Okay. Now let's create the new coins, which is going to be coin. There was one put, but figure out the name of the function which is used to like take the value back, which we put in here. So we need to take the value back from the balance. So one is this, which is from balance, but I think this takes the entire value from the balance, and we don't want to take the entire value from the balance. Then there is this put, which is used to move the value to the balance. Then there is take, which I think should be the right function. Yeah. So it should be take, and we want to take it from the staking pool. Yeah, the mutable reference of this. This takes the context also. Okay. I think this should be it. Okay, so now we have a slash function, a stake function. Let's also create an unstake function. So unstake function should also take a staking pool, which should be a mutable reference to the staking pool, and it should take the staker cap, like not the reference but the actual staker cap. We don't really need any condition over here. Just one, the owner should be the one who is unstaking it. So let's put one condition over here, which is taker cap dot owner double equal to the tx context send of the context. Let's create one other error, which is unauthorized. Okay, and we have this unauthorized here. Okay. Incompatible type. Expected this. Okay. Somehow we want to burn this taker cap from here. What if I just do this? I'm not sure if this will compile, but let's see. Let's take the coins. So let coins equal to this, and then do a transfer, public transfer of coins to staker owner. we don't need this condition if we are only returning to the stake cap owner. Maybe we don't need this, or let's just leave it. Okay, let's try to compile this. I think this can fail. Okay, it's failing on line number 22nd. Okay, on this one. Non-composable transaction to the center. The transaction center coming here, returning an object from a function. A caller to use the object and enable composability via programmable transaction. Returning an object from a function. Transfer of an object to the transaction center address. Oh, this is the real error. Does not have the key. Okay, so we need to create a key for this. ASCII IP Okay, so this is on line number 69. Unused value without drop. Yeah, so we need to find a way to delete this staker pool. Sorry, not the staker pool, the staker cap in unstake function. So maybe we can have a draw function here and see how this works. Store constraint is not satisfied. Okay, we need the store also. Okay. We need to store here also. The arbitrary constraint not satisfied. It's on line number 24, which is here. The struct has declared the ability drop, so all the fields required the ability drop. Okay, I need to check how do we drop staker cap. Let's see. On the standard, so there was a guide in the Sui 101, I think, which was create tokens, was not this one. Shared versus zonable object. I think in this they were dropping some objects. I just need to find out how they were dropping it. Okay, so if we just delete the keys, the object would be deleted, I think. So yeah, I'm not really sure now. Okay, this worked this time. So if we remove this and do self move. Okay. So if I just remove this, will this still work? Okay. Let's just put this. Okay. So this is compiling at least. Now in the next video, I'm going to try to write some test for this. And thanks for tuning in for this session. And I hope you all have a great day.